Hello guys! In the last lecture, we talked about the first type of feature generation, manual feature engineering, which is not difficult by itself, but if we have hundreds of variables spread across dozens of tables, this process is not feasible to do by hand. Ideally, we want a solution that can automatically perform transformations and aggregations across multiple tables and combine the resulting data into a single table. So today, we are going to talk about the second type of feature generation, which is automatic feature engineering. For this, we are going to use feature tools, which is exactly the solution we are looking for. This open source Python library will automatically create many features from a set of related tables. Feature tools is based on a method known as deep feature synthesis. Stacks multiple transformations and aggregations operations, which are called feature primitives in the vocabulary of feature tools, to create features from data spread across many tables. We will use the same dataset we used in the last lecture, but this time, instead of applying manual feature engineering, we will apply automatic feature engineering using feature tools. First, let's start by importing feature tools and load the dataset. Before digging in, we have to know a few concepts about the library: entity, entity set, relationship, and feature primitives. So what is the entity? An entity is basically a table or data frame. For our case, customer, session, and transactions are our entities. Each entity must have an index, which is uniquely identifying column. For example, customer ID. Now entity set is a collection of tables and the relationship between them. Now let's create an entity set called customer data. And let's create two entities, transactions and the products. To create an entity, we have to specify its name, data, and index. The first entity we are going to create, we'll give it the name transaction, and the data frame is the transaction df we created before, and the index of it is transaction ID. The second entity we are going to create, we'll give it the name products, and data frame for it is the product df we created also before, and the index is the product ID. Now what is relationships? We have to define a relationship between the entities in our entity set. The easiest way to think about a relationship is the parent-child analogy, which is a one-to-many relationship where for each parent there can be multiple children. In our example, the customer data frame is the parent product, where each customer can buy many products. These relationships are what allows us to group data points together using aggregation primitives and create new features. We will create a relationship between the product entity and the transactions entity using the product ID key. Now we will add the relationship to our entity set. Finally, we will use feature primitives. Feature primitives are basic operations that we can use to form new features. They can be applied across datasets and can be stacked on top of each other to create complex features. They are grouped into aggregation and transformation. We saw an example of them in the last lecture. Now to use the DFS function, let's set the entity set to ES we created before and set the target entity to transaction. We will also set the aggregation primitives to mean, sum, and mode. Finally, we will set the transactions primitives to month and hour. Now let's see our new dataset. Now let's see our new features. We notice now how we generated 12 new features. We now have all the pieces in place to understand deep feature sinuses, or DFS. In fact, we already performed DFS in the previous function call. A deep feature is simply a feature made of stacking multiple primitives, and DFS is the name of the process that makes these features. The depth of deep features is the number of primitives required to make the feature. The higher the depth we set, the more features we get. Now let's copy the last code we wrote and set the max depth to 5. We see now how we generated more features by only changing the depth of the DFS algorithm. We can let feature tools automatically generate many new features using the DFS function without passing any primitives. We only set the max depth, entity set, and the target entity, and feature tools automatically tries many combinations of feature primitives to the ordered depth. We see now how we managed to generate so many new features by doing this, but we are not sure if all of these features are good for our model. So what we are going to do in the next video is to learn how to perform feature selection, which will select the best features for our model. So that's it for today's video, and see you in the next lecture.